Okay, this is section 8.8, problem 27. I picked it because it had a negative out front, and I really wanted to make sure we did one like that. First step, again, they ask us to find our vertex and the axis of symmetry. Look, can't say that. And then use those and then at least 4 other points to graph, okay? So I'm going to go ahead and make a table down here too so that we can plug in the 4 extra points. Sometimes I like to write the vertex down here too once we find it. Okay, so let's start with the vertex. Remember, we're going to label this y equal ax squared plus bx plus c, and a is the number in front of the x squared, and in this case, isn't it an invisible -1? Now, notice, since the a is negative, it's going to be, the graph will be reflected. That means it's going to be reflected across the x-axis. Well, let me just put reflected. That means it's going to open downward. So when we put our vertex on our graph, it's going to be right here, and this is going to be what we call our maximum value. It's going to be the highest y value we can get. I'll also talk about domain and range here in a little bit, so let me write it over here so I don't forget. Domain. Now the domain, I can plug in any number I want to, so we're going to say it's all real numbers. And the range is going to be a little different here, and so we'll talk about it as well in a minute. Okay, so if we're going to go ahead and pick off our A, B, and C, we already put A was -1, B is -5. Remember, I take the negative with the number if it's out front because it tells me the sign. I could have written that as plus -5x, and you would have seen the -5. My C is a +6. Now, one thing, if you remember, when you're in this form, there are other forms of writing quadratic equations, but when you're in this form, which is standard form, the number on n is the y-intercept. So I already know I'm going to have a y-intercept at 6. 1, 2, 3, 4, 5, 6. Here's the y-axis. 6 is here, and this is going to be my high point because my parabola is going to open down. So it's the vertex, and it's the maximum. Wait, I don't know. I know that's my y-intercept. Actually, I don't know if it's the high point yet. We need to plug it in and find out, and I jumped the gun on that. So no, that's probably not the vertex. Sorry. So let's go ahead and find out what that is. If you remember, we use the same equation for the vertex and the axis of symmetry, and that's x equal -b over 2a, and it's helpful to put the parentheses so you plug in any negative numbers correctly. All right, so let's see. My B was -5. This is not going to be pretty, unfortunately. My A was -1. Okay, so on top I have -5, which is 5, and on the bottom I have -2. So my vertex is -5/2, and you might want to graph that as -2.5. So at -2.5, I'm going to hit my high point here. Ooh, I bet my graph's not big enough. We'll just count up and pretend it is. If I want to know what this is, that's a real pain to plug in, isn't it? Because our equation's gotten pretty large. You can do it by hand. You can type it into the calculator. But another way to do it would, you'd have to type each one into a regular calculator. If you have a graphing calculator, you can type in negative, which is the number on the bottom row, and then x squared, and then a subtraction sign, which is along the side in between the multiply and the add button, minus 5x plus 6. And then I can hit second table, and I can get these values at, let's see, 2.5 is not going to show up because it's in between whole numbers. So if you've got a calculator, you can go to table set, which to get to there you hit the blue button and then the window button on the top row. I can change my calculator and have it count by 0.5 so that 2.5 would show up. And once I do that, I can hit second graph and go back to my table, and I'll see that at 2.5, at 2.5, I'm sorry, I'm supposed to be looking for -2.5. I'm not awake yet. So I'm going to, on my calculator, I can back up to -2.5, and I'll see that I should have 12.25 here. So you could get that by hand, but it's a real pain. That's why I recommend a graphing calculator. It was supposed to be on the list of what you needed for this year, but somehow it just didn't make the list. I don't know why. If I graph that point, since it's the vertex, it's pretty important. Let's go ahead and graph it. It is negative 2.5, and then up at 12.5. Well, this 6, this is the y-intercept. It's just not the vertex. So if that's 6, up another 6 and a little bit more would be about right here, wouldn't it? So it's way off my graph, but you see where I just put that red dot? That's where my vertex is going to be. So that is going to be my maximum value. If I know that that's my vertex, I can also write in my axis of symmetry now, because remember, that was a 2-for-1 formula, wasn't it? It told me the x-coordinate of my vertex. I had to get the y by plugging that x into the equation. And I used a calculator for that because it's just so much faster, okay? Now, if I were to give you a quiz or test, I would make sure I gave you something that was not this hard so that you could do it by hand easily. But just know that a graphing calculator is going to make everything easier as far as getting points if you don't like plugging it in and taking so long on a problem. All right. Because that was the x value, my axis of symmetry is a vertical line through that vertex, so it's going to be x equal negative 5/2 or negative 2.5 as well. I'm going to draw that in a different color just so it shows up really well. That's this green line, which is, it's not really part of the graph, it's invisible, but it splits the graph into mirror images of each other. And so that tells me I can go ahead and graph some more points here. If I've got a point on the y-axis 2.5 away from that green line, then 2.5 away on the other side, I'm going to have another point. Okay. Now, my vertex was at negative 2.5, so let me plug in some numbers to the left of it. Let's try like negative 4 and negative 3, and then to the right of it, maybe we pick, we already know what it is at 0. Maybe we pick negative 1, and then maybe we pick 1. Those would be some other values I could pick. Well, if I've got a graphing calculator, I don't have to do all that work, do I? Because I can just let the calculator do those simple calculations. At negative 4, my y value is 10. So at negative 4, negative 1, negative 2, negative 3, negative 4, I'm up at 10, which is, we'll say that's about here. And so if it's that far away, I'll have another one over here about the same distance away. At negative 3, I'm at 12. Okay, so at negative 3, which is really close, it's just almost there. So there'll be another one almost there on that side. At negative 1, I'm at 10. Negative 1, 10. Oh, actually, I had already graphed that because I did. Negative 4 had a value of 10, and I used the axis of symmetry. So I've already actually got that one graphed. And at positive 1, you can see if you're looking at your calculator that you've got the 0.06. That is your y-intercept. The number on the end in this form is the y-intercept. At 1, I have a value at 0. Now let's think about that. How far is that from the axis of symmetry? 1, 2, 3.5. So a half, 1, 2, 3 on this side. Here's my other point. Now, that gives me enough to graph this and get it really well graphed. But I want to say something about some of these points here. These points, I'm going to highlight them in blue. Right here are very important, because if I tried to solve this equation, I don't know if you remember this, but when you solve a quadratic equation, you either factor it and set the factors equal to 0, and that solves it, or you could use the quadratic equation, which nobody really wants to do if they can get away with it. But when you solve, these blue points are your solutions. So I'm going to write that out to the side here. These are the solutions. They are also called the zeros because in that spot, y is equal to 0. They are sometimes called the roots. But they are, our x-intercepts are our solution. Those are our solutions right there. And we can tell from the graph what our solutions are without even factoring this, as long as we've done our math properly, and a calculator helps us do that a little more accurately, because we didn't have to worry about making little bitty mistakes there, did we? It just, worked out. Okay, so this is graphed. We know our axis of symmetry. We know our y-intercept. We know our vertex, and we actually know our solutions here just because of the points that we picked. It kind of accidentally happened, but But I could have found those by setting negative x squared minus 5x plus 6 equal to 0, factoring, and then setting each factor equal to 0.